So we'll just get straight into it. I'm not going to waste time as we have more material to cover. So this is my outline today. As previously, I always try to recap what we actually covered in the previous part. So I'm going to very briefly go over what we covered in part 2 for those of you as a reminder, and then talk about the concepts and the motivations behind model registry. What are some of the problems that people normally face today and how we actually address that particular problem. And then share with you what the typical model registry UI is, along with how people actually use the APIs as well in part as part of the workflow. And then I'm going to give you a short MLflow managed demo on registry. This particular notebook is going to be running on an enterprise version of the Databricks. You won't be able to run that on the community edition because the model registry is not available. So you'll just have to follow me, but you can still have access to the notebook. It's in the GitHub repository. Under notebooks, there is a DCE file. You can actually load it up in the community edition you want, but you won't be able to register the model because we don't have the functionality yet. And then once I'm done with that, we'll try to go through a couple of demos on the local host. And presumably those of you who have been courageous enough to install MLflow following the instructions I gave in the registry will be able to follow me. If not, don't worry about it. Just look at my screen and see what I'm following through and try to explain through that. We won't have time to troubleshoot if you're actually having trouble on your local host, but that's something you can probably do it later on. So with that, there's a link over here for the model registry, and let's go into it. So last two parts I covered, in part 2, I covered sort of 2 essential components which were kind of related and they had the same motivations, the MLflow projects and MLflow models. And right at the start, I sort of was quite emphatic to say that MLflow was actually built on the premise and proposition that we wanted to do things in an open manner. We wanted to actually support all the common libraries that people actually use and have the ability for them to be able to use these particular projects in diverse environment. And so in order to do that, it poses a certain challenges. One is that how do you actually recreate the particular model? How do you actually recreate the project that you initially started with to reproduce in a target environment? For example, Leila might actually produce a project and create a particular model, and she wants to share with Lan and Shannon. How can they actually reproduce that on their particular machine? And that poses sort of an interesting problem. One is that because each tool has a very generic way of packaging material for the target environment they want, and people run the execution or target models in different way. People run it on localhost, others run it in notebooks, others run it in the cloud. And even though if you might capture the initial data and some of the dependencies, the target environment might have a different dependency. So the problem was that how do you actually recreate that? And the solution was that we came up with a way to say, what about if you actually have the ability to capture the entire project, MLflow project that you're actually doing in a manner so that it becomes like a unit of execution. So you capture all the essential dependencies that you have in terms of the code that you're going to run to create your particular model, all the library dependencies that you can have to create the particular model, all the input data, all the training data, all the validation data you have, and express that in a config file so that people can actually take that particular unit of execution and then execute on the target environment. And this could be a local execution, or this could be sometime remotely. And those of you who come from, say, the Unix background, and I'm dating myself over here, is that think of this MLflow project as a make file. If you're used to dealing with make files, if you're used to dealing with a lot of open source, when you actually download a particular open source project, it normally actually creates a config file for you, creates a make file for you, and then executes the make file to create the unit of execution that you can actually run now locally. And it will try to figure out what environment you're running. It'll try to figure out what architecture you're running. And based on that, it will use the right compiler to create that. So think of it in a crude analogy, it is like a makefile. And so how does it actually do that? Well, there are 2 essential ingredients that actually make up the project. One is like a simple directory that has an ML project file. And that, if you look at the ML project file, it's like a Kanda YAML file that has dependencies that express these are my entry points, and this is where I'm going to create a particular program. This is my command that you should use to execute that, and here are my input parameters those are the default. So you can think of it, this is an expression way of really creating your project file. And the conda file is the one that encapsulates all the dependencies that you actually need to execute your particular project, or in order to create the particular model that, say, that Layla actually created and wanted to share it with the two other data scientists. The second ingredient is that you can now actually execute all of these projects that you actually created in the GitHub repository. You can share with others, either using the command line utility, or you can actually use it programmatically. Or if you do a checkout of the particular GitHub repository, you can seed it into that particular directory and run this particular command. And you can run that with your parameters, or with the parameters which are default in how somebody who shared that project with you created initially. And the second ingredient is the conda file. And the conda file allows you to say, these are all the dependencies that my model depends on, that I actually used initially in my development environment that I use. I use scikit-learn, I use MLflow, I use Pickle, I use TensorFlow, all that. Anything that you actually use to create that particular model are sort of captured in this particular conda file. And together, it sort of gives you the ability to recreate and reproduce that. So MLflow project, in essence, is nothing but a directory structure that captures what it requires for you to actually create a particular model. So that, essentially, is what MLflow project is. And once you actually have that, you can put it in the Git repository publicly and share it with other people as well. Similarly, MLflow model had the same idea. The motivations actually came with the same idea, as that we wanted to support people to create all these models in all these different frameworks that you actually see on the left-hand side. And we want to be able to have them deploy these particular models that you actually create on the right-hand side in these different environments. And as the organization get larger and larger, you might actually have different form factors whereby you actually want to deploy this particular model. And how do you actually do that? How do you actually say, well, I'm going to have TensorFlow to be able to deploy it on Kubernetes, but also want to run it on Docker. And in order for me to do that, I have to have like one by n different ways of figuring out how am I going to capture this particular model and how am I going to execute or deploy it on that. So the idea there was to sort of create an intermediary flavor, right? Instead of having it n-by-n combinations, we say, what about if you actually create an intermediary level, which actually captures what we call the flavor of each and every model. And so if you have n number of frameworks on the left-hand side, we can actually create the native flavor in which the model was run or created or trained. And then we can actually have several other flavors that we can actually add. And then based on that, if the model is deployed, say, on the target environment, if the target environment understands the flavor in which it can actually load the model, then it can actually do the scoring as well. And this sort of gave us a very generic way of capturing how a model can be encapsulated and then deployed in the diverse environment. And I think there was an interesting question that actually was posed at the end of the second session, where somebody said, well, what's the difference between MLflow models and MLflow project? They seem to be very different. We can think of it, MLflow project is a producer of an MLflow model, right? And so you can think of it, MLflow project is nothing but a make file that allows you to create your model that you actually want to do. And then model is what you actually sort of deploy it on this diverse environments. And depending on where you actually are deploying that particular model, that particular flavor can be invoked by the inference engine to actually do your scoring. So how does MLflow model does that? Similarly, with project, you actually have the ability to log a particular model in the MLflow flavor, and the API, the Fluent API that you saw in part 1 and part 2 as part of tracking is one way you do that is by using this API called log model. And when you log a model, what happens underneath that we actually create a directory structure for you, and underneath there are a few files which actually sort of make the essence of the model. One is your YAML file called ML model. And that sort of captures a couple of things. You got all the metadata associated with that. And then you can see there are two flavors that we actually create. The native flavor here is a TensorFlow in which you actually did that. And a couple of other metadata is, what directory it contains and what are the signature he actually uses to load the model and do the prediction and inference. So that's particular one flavor. The other flavor now is a generic flavor, what we call the Python functional flavor. This is actually quite powerful because this allows us to be able to deploy this particular model in any environment that is running a Python, and you don't have to worry about the underneath infrastructure, whether it's TensorFlow, whether it's Keras. You need minimal library of TensorFlow to load that particular model and execute. But what you're doing is you're actually encapsulating that as a Python function, and then just using the predict function to actually do that by providing. And this allows us to say, I can take that particular model and put it in a Python environment that's running in the Docker, or I can actually use this Python function and load it into a Spark and then use the UDF to do the batch inferencing and so on and so forth. So this is actually quite a powerful notion by saying, if we have this particular flavors, we have the ability to generically detect this model and deploy in diverse environments. And to give you an example of what I mean by these particular flavors, that think of that you actually created all these different flavors of Python. You might use a PyTorch to create a particular model, and you save that by using a PyTorch, save log model. It has a Python flavor. You can have a scikit-learn, you can have Spark, you can have TensorFlow and Keras. And then the end result, when you deploy this particular model, what you now have is the ability to load that particular as a Python function and then just invoke the predict function on it by supplying the pandas input frame. So this is actually quite powerful. And then you'll actually see, we saw that in part 2 in some of the notebooks, how you actually had a Keras model. We executed the particular model using project APIs. We loaded the Keras function that we actually executed as a Python function, and then we did prediction on it. So this is actually quite imperative in us as ability to deploy this in diverse environments. So that, in essence, is what project and models were that we actually covered in part 2. And you can actually look at the videos to go deep into how these are implemented and how you can actually use the APIs to create a particular project, how you can actually use the Python function to load a particular model of particular flavor, and how you can actually deploy them as well. So that, in essence, is what projects and models are. Now I want to shift the focus to cover the main topic of today, which is the MLflow registry. And registry is the last component that we introduced in 1.7, and it was recently GA'd. And in essence, that sort of completes the entire life cycle, where people can now sort of register the models that they have developed, and other people can discover what the models are. You can annotate the model. You can put that in the central repository. You can think of it as a GitHub of all your models, but except that this is within the organization, and people can discover that model and do that. So what are some of the problems in absence of a model registry? Say you don't have a model registry. How do people actually work? Or what do they actually do? Well, I mean, it's good if you actually are a single developer. If you're by yourself, or maybe 1 or 2 people in a group, it's very easy to say, I'm just going to create a classifier, and if it's a Keras model, I'm going to tag that as a version 2. And if I rerun another experiment, I'll classify as a tag as a 2. And then if I have, a month down the line, I can sort of put all this annotation and tags to it, which is fine. I mean, it's well and good if you're actually dealing in a small environment. But it sort of poses interesting questions, right? When you're a large organization where you have hundreds of developers and you develop loads and loads of models on daily basis and weekly basis, there comes a point where you actually want to ask questions like, well, where can I find the best version of this particular model that Leila developed, that Shannon developed, or Len that created a classifier? Where can I actually find those? How can I search those models? How do I find out how this particular model was trained? And this is the whole idea about provenance. How do I actually figure out and look at the history of how this particular model evolved over a period of time? How can I track some of the documentation associated with it? It's really important that you share that information in how you train the model, what the parameters we use, and so on and so forth. And then how can I review the particular model? If I want to integrate this part of my model management lifecycle with, say, my CID, CD tool, how do I actually inspect the particular model, check it out, run it to make sure everything is fine, I'm happy with it, and then I, as a reviewer, can then manage the stages of its next evolution. How do I actually do that? And this becomes imperative in a large organization, right? And so the whole idea was with model registry was this vision that what about if you actually have a central repository, a controlled central repository that allows you to do all these different things, where people can use the tracking API to actually use the experience the model. When they're happy with it, they can actually go and register a particular model they actually have created. And then this particular process of reviewers and CI/CD tools can actually look at the particular model, go through the evolution, go through the testing, do the A/B testing, whatever they're actually required to do, and then make the appropriate transitions as they go from developments to staging to production. And then finally, if the model is of no use, they can archive it and eventually delete it. And once you actually have a model registry, the downstream people can check out a particular version of the model, can check out a particular stage of the particular model to use it in their automated jobs, or they can use that to do some REST serving and so on and so forth. So that, in essence, was the idea behind model registry, is to have a central repository where you can actually put stuff and discover and so on and so forth. And so, if you look at what the model registry UI or workflow looks like, you have a central model repository that actually gives you a unique name version of a particular model. You can actually keep track of all the different stages, as I said earlier. You can actually inspect different versions of the model. I can actually find out what particular versions of the model are registered with this particular model called airline display. I can look at the descriptions and annotations and links and PDFs and all the documentation associated with all the lineage that I can keep track of. And this sort of gives us a very distinctive way to create two workflows that are very common in how people actually use registry. And I think those are not very different from how you actually use, say, GitHub in your compile edit cycle. And so the workflow for UI is very simple. You actually sort of train your model using the MLflow track API. Once you're actually done with it, you're going to go to the UI to figure out what my artifacts are, what my parameters are. We saw that in part 1 and part 2, what the UI looks like. And then towards the end, you'll have the artifact where you want to say, okay, I have this particular model. And when you click on that particular model name under the artifact, you get this button on the right-hand side that says register, right? And when you register, the developer would normally register to create the first version of the model, or if the model exists, then it will create the next version available, or it will create the subsequent next version of the model. And they go ahead and register the particular model called scikit-learn. And what this happens at this point is that the registry will now create a version 1 of the model, right? So essentially the developer takes a particular model, goes to the UI to say, okay, I've tested it, looks good to me, I'm going to go and register it. And I'm going to notify my reviewer to say, okay, I'm ready to actually make the transition. And so the reviewer can actually come in and annotate or whatever they actually require for that model to be sort of more comprehensive and digestible for people who are going to use down the stream. And he or she can actually take that particular model and make the appropriate transitions from, say, none to staging to production to archive. And then finally, if more versions of the model are created by the developer, he or she can actually go in there and then create different versions. And you can have different versions of the same model in different stages. And this gives you the ability to do a lot of A/B testing actually one. And once you have all these different versions of the model available, now you have the ability for people down the stream who can actually use the APIs to check out a particular model or use that in their automated daily jobs to do batch inferencing, or they can actually use that as part of the streaming REST serving at that point. So that essentially is the model registry UI that you actually use, the workflow that you actually use. Now, the similar way you can actually do that with the APIs as well, right? A lot of people, developers, really don't like to use the UI. They can do pretty much the same thing from the IDE or from their Python file. And you actually use the model registry API, the client API, to go ahead and register the model, right? Now here I'm registering a model called weather forecast, and it's going to go ahead and create either create a new model called weather forecast with that particular URI. And if one exists, then it's just going to create the next version of it's available. And then I can, or I can actually do it from within my MLflow run where I'm tracking the server, and when I'm done with it, I'll just go ahead and create registers as model weather forecast. The reviewers can now query the MLflow registers to say, get me this particular model. Now transition it over to take the version 5 of the model and transition it from staging to production, or from none to production. And then people down the stream can use the APIs to say, go ahead and here's the model that I want, weather forecast, and the stage I want to check out from is production. So I'm going to go ahead and check out this particular model. I'm going to load now this particular model into my code, and I'm just going to invoke my credit function to do my scoring. So that, in essence, is the gist behind the model registry API. You have two distinct ways to actually interact with the model registry. One is using the UI to do that, and if you are one of those developers who hate UI and you want to do everything with API, which is a good thing, you know, some of us love doing that. You can do that through the registry API as well. And the model registry is actually backed by two stores in the back, right? Since 1.7, we now support the model registry to be a part of SQL Alchemy store, where we actually put all the metadata, all the runs, all the versions, everything, both on the local host. And then on the MLflow managed version, we actually use MySQL to store all the running data. On the local host, you can actually just run SQLite to look at what your database looks like and make queries if you actually want, if you're curious. And then the artifact store is the one where we actually store all the artifacts. And we talked about what artifacts are in the training. These are the log files. These are the input data. This is the training data. This is the artifacts that you might create, such as plots or feature matrix or confusion matrix. Anything that you actually think that you want to share, make it part of that, you actually store it as an artifact. And then when you launch the particular server for people to connect to your tracking server, you can just provide those particular as part of the command line arguments and run with it. So that, in essence, is what the backend is supported by the model registry. And these are all the artifact different stores that we support, and we can actually you can use your model registry with any of these SQL compatible Alchemy stores as part of the entity and metadata. If you're curious to know what it looks like, if you run this on the local host, you can just use SQLite, which actually comes with Python 3. You might have installed it and you just run it as part. And this sort of gives you the schema, what the schema looks like. These are all the different model versions that you actually create. The registered model are the ones that it look like. And then these are pretty standard schema that you actually use. And you can sort of pretty much take this particular schema and import it and export it if you want to change your database or you want to do backups. That's sort of a good way to do that. So to cap, essence, the fourth model is the model registry. And I say it is a central repository that allows you unique name registered models so other people can search, other people can discover, the data teams can actually use it in a very collaborative manner and in a very controlled manner. And the enterprise features has rollback access control. So you can actually provide permissions to who can actually check in, who can check out a model, who can make the transition and so forth. So that is an essential part of registry where you actually have a control access. So you can monitor, you can prevent accidents by people inadvertently taking the one model that's not really ready for prime time and putting into production, where the reviewers can actually block that particular request, so on and so forth. As I say, it provides you sort of two very unique registry workflow APIs. You can do that in UI, or you can actually use all the registry operation using the APIs as well. And gives you the ability to have multiple versions of the same model. And I think you'll never have one version of the same model. You're going to have multiple versions of the model throughout your development cycle. And this gives you the ability to choose the best model that you want and then make the appropriate decision whether you want to deploy it in a particular stage or is it ready for prime time. And model stages gives you the ability to transition that. And then finally, it has the ability for you to actually integrate with other applications, including if you're doing forecasting, that you can actually check a particular model and then do a forecasting, or you can actually integrate with Jenkins APIs on your nightly basis to test to see if the particular model is ready for production. So that, in essence, is what model registry is. And then just to recap of all the three parts that we actually have talked so far, we talked about part 1, part 2, and part 3, and now we actually have sort of a comprehensive picture of what these 4 components are, how they work together. They're not monolithic. You don't have to use all of them. You can choose one of the 2, but they work very closely together, and they have a set of APIs to do each and every different operations you want to perform in there. So it's very modular in fashion and greatly simplifies this entire life cycle that we talked about in part 1. And if you have started using it in part 1 and part 2, and you've been doing the homework assignment, probably you'll come to the conclusion, I hope you share that with me, that it is easy to install, it is easy to use. The APIs are very fluent, very Pythonic in nature, and it gives you a great develop experience. They're easy to deploy. In other words, you can actually use it locally, or you can actually use it remotely. As I said, the Python's available in the programming languages that you like, in Python or in Java or in R, and soon to have one in Scala. All the REST APIs are available for you to actually talk to the tracking server or the registry from any application you want. So you're not tied to just using Python. If anything that uses a REST API, you can actually use those APIs to connect to all these different components. And there's a great visualization tool UI that allows you to compare and contrast experiments and select the experience that you want as an ability to select the best one and then register that with the model registry in order to have this endless cycle management. So that, in essence, is what model registry is. And so with that, I think, are there any questions on the panel that the panelists think I should address? If not, I can move on.
I don't think so. I don't think we have any questions. Actually, maybe one question.
Jules, you must be doing such an excellent job that no one has any lingering questions.
Oh, well, that's very flattering. Either that or I put them to sleep. Okay, so let me just go to my notebook. Now, this particular notebook is available for you. It's in the notebook folder in the GitHub. There is a DBC file. You can upload that. However, I do forewarn you that this is a managed version of MLflow registry. So some of the features over here that you're going to see are not part of the community edition, and they're not part of some of the features in the open source. So you won't see that. You won't be able to run that in the community edition, but it's good to actually have as a sample example. So if you actually ever want to try a managed version, free trial for 30 days, you can actually load this particular registry. Load this particular notebook and play with it, and you'll see the merits of what I mean by having a very controlled access and some of the enterprise features which are available for managed flow on Databricks. So this is a machine learning forecasting wind power application. It actually takes 3 features, wind speed and air temperature, to predict what the power consumption kilowatts is going to be of this particular wind farm. And it takes 3 recordings every 8 hours and then gives you the aggregate total at the end of the day, what the kilowatt consumption is. And the data set can be gathered from the National Wind Toolset kit. And essentially, as I say, it takes 3 recordings at 8 hours a period, and then gives you the aggregate over the period. And what we want to do is we want to sort of use random forest regression to predict the power. And then we are going to use a couple of models to actually do that. Now, if you were here with me in part 1 and part 2, you probably see that I had this notebook run called run.class init. And these are my classes that I normally use to sort of delegate all the work that I need. So a good abstraction way for me to put all the code that I actually need away from it. So my notebooks are not very cluttered. The notebook becomes the driver. And so when I run this particular classes in it, it's going to go ahead and execute those classes or initialize those classes. So then I have the ability to use them in my particular notebook. And then just to give you an idea what these classes are, we can actually go to the init classes, and some of you are probably familiar, you've seen this, it's the very same pattern that I've used in part 1s and part 2, where I create all these high level classes that allow me to be able to use them again and again in other places. And then this is just a utility classes, which is a static class that has static methods in Python that gives me the ability to do, get to training data, get validation data, get slices of weather forecasting that I actually need for 5 days or 6 days. So that way I can plot things in a nice modular way to compare my forecast with my predictions. There is the random plotting utility that gives me the ability to plot things. And that way my code, my main notebook is not cluttered. Everything is sort of dedicated to this particular task. And in the main class that I have 2 models that I'm going to use to create 2 different models. We're going to register it when you're going to use the best one. This is the Keras model. And the Keras model has the constructor that takes in the input parameters I need to construct and compile the model. And then here's my gist of the program called MLflow run. And you'll notice that this is now, I just have one call called MLflow.keras.autolog. And this is a new feature that we have actually added. And we've added to TensorFlow, we're going to add to scikit-learn. The one exists for gluon and XGBoost and LGBM. And all it does is that you don't have, using the tracking API, you don't have to log each and every metric, right? You might have hundreds of metrics that your code becomes rather cluttered. So when you use this one call, MLflow Keras autolog, it figures out what the metrics are that you're actually computing with this particular algorithm. And I'll go ahead and log that for you automatically. So your code now becomes very simple, very easy to use. And once you use that, it will log the metrics, it will log the model, and so on and so forth. And then you normally use that before you actually invoke your fit program. And then I have another class called LFR model. You've probably seen that in the previous. It's the same thing. I just have an MLflow run that actually takes and trains the model, and then at this point registers the model where if the model exists, then it will create the next version of it. If it doesn't exist, then I'll create a model with this particular name. So that, in essence, is what my code looks like. So let's go back to my notebook quickly, and then run this code. So I'm going to load this particular file, which is about, I think, 2,500 entries or so. And let's look what our file looks like. So we got 3 recordings, as I say. I've used this as an index on my pandas data frame. And then this is the power that I actually want to predict. And if you're just curious about to see what the data looks like as a distribution, we can actually just use this particular pandas call to find out. So we can see the mean average is about 2,400 kilowatts per day. So let's do the first thing. Let's get the training data and validation data for our first model. And then we're going to use a Keras model to do the linear regression. So we're going to have one input layer, one hidden layer, and then one output layer that actually gives us the output. And then over here, it's very simple. I'm going to have 3 input parameters that I'm going to use. These are my hyperparameters I'm using to create 3 different instances of model. And all I'm doing is create an instance of a Keras model and then execute this MLflow run. And then it's going to do all the logging for me. It's going to do all the good stuff that I actually need. So this way, my code over here is less cluttered. It's quite clean. And I can share those classes with anything. You can think of it as nothing but like a PyPy module that you actually just install by importing that. So this is going to run with 3 different input parameters, input units. The loss is I want to compute as MSE. And notice that as these things run, it's going to go ahead and create the losses as I go and create the mean square error. And this is going to take about a couple of minutes. But it's actually running in real time using Keras, and the backend is TensorFlow. And once we've done that, we're going to go over and go ahead and create and register the model with the model registry. How much time we have? All right, so that ran, didn't take that long, about a minute or so. And then I can actually go over here and then go ahead and register this particular model, right? So I can go to my runs as we saw in part 1 and part 2. The MLflow UI is part of the notebook. It's actually integrated. You don't have to run a separate UI to do that. It's part of the notebook. It's actually quite convenient. And when I click on that, I get a summary right away on this right-hand column over here of all the runs that I actually did that resulted from that particular call. And if you see that, this is all the parameters which were automatically logged, right? I didn't have to have log param, epochs, log param, Appleson, log param, all that. All these were automatically logged to me because of the one call called Keras auto log. So I can actually go ahead and look at these models to see what they look like at one quick glance. And these are all my particular models that I actually ran, right? I ran this one just a minute ago. And let's go ahead and pick up the best one that we actually have. I can actually go ahead and compare these models if I wanted to. Side by side. I can actually go ahead and look at their validation loss step by step to see what they'll actually look like. And this is something very similar to what you would get if you ran TensorBoard and then log the Keras as a callback function to write things to the log directory to actually get all that. So I can actually look at my validation loss for each and every epoch as it actually going down as I'm training. So we'll go ahead and pick up one model that. And then let's go ahead and put that into production. So you can see when I click on this model, I get this particular button called register model. So I'm going to go ahead and register model, and then I go ahead and create this model. Now there's a lot of other models which people actually create in the registry, but I want to create something called power forecasting model. We'll do that. Create a new model. And I'm going to register this, right? And when I register it, as I said, you actually get the version 1 of the model in your registry. And I can go to that particular version 1 model and I can annotate that if I want, or I can make the transition, or I can make a request to make the transition. So I'm going to go to my model registry and go ahead and put in whatever description that I want over here. So I can type in whatever description I want. I can put images over here. I can have my entire Wikipedia if I actually want over here. So this way it gives me the ability to annotate this particular model and share with people who actually, when check out this particular model, they have the ability to do that. So next thing I'm going to do is I'm going to request this model to be transitioned, right? So I have the ability to transition the model from one stage to the other one. So I'm going to go ahead and request this transition to go into production. I'm being a bit overconfident, so I'm going to ask our chief data scientist, Leila, can we put this in production? Please. And you can see there is a lineage of all the requests that come in, and Leila is going to come over with, and she's going to reject that. Are you bloody mad? Spell first. So we can say, as I go through these actions in my UI, we actually keep track of that. And so I'm going to go back over here and say, okay, let's go ahead and she's going to run some testing. It's okay, this seems like good. I'm going to go ahead and transition that. Looks good. Let's put this in production. Right, so I have my models over here. I can say power. And I have this particular forecasting model. At this point, I have one in production. And so let's go back and go on with our notebook. So the next thing I'm going to do is go ahead and perform the transitions and integrate that with the forecasting application. So this is my power forecasting model. And one way, as I said, you can actually load different ways of the model. I can use a Python function to load my version of the model, or I can actually use one that is a production model. So let's load this particular model, which is the same one as the production, or I can actually load a production model, which is what we just transition something into production. And this is sort of the API that CI/CD could actually use to test this thing. And now I can integrate this particular model with my power forecasting application that I have, that gives me the ability to say, I'm going to take this production URI and I'm going to test this, my wind data, to see how did my prediction happen over a period of 5 days. And so we're going to plot this forecasting model with my production to see how the model fared. So this is my true values for the prediction that I did. Right, these are my true values, and the blue ones are what the model actually predicted. And it seems that it's not bad. It's tracking well. So I'm confident now that this model is fine. I could have done this in staging, and then Leila could have gone, okay, I looked this particular forecasting model, I tested it, it seems like good, I'm going to go ahead and make the transition into production, and then she can actually make that transition into production. But at the same time, normally in practice, you're not going to create one model, you're going to create multiple models. And the whole idea behind, the whole premise behind MLflow was for the data scientists to give them multiple ways to create 2 different models solving the same problem, and then they can evaluate which is the best one and then use that as part of the either A/B testing, or when they're confident that one is better than the other, they can choose that one and then go ahead and deploy that. So now the next model we're going to do is the random forest regression model, and these are the parameters I'm going to use. And the idea here is very similar. I am creating 3 different models. I'm using 3 different estimators. And then over a period of time, you can actually use different hyperparameters to make sure that you actually get the best model. But this actually gives us a good idea of what all these models look like. So we're going to go ahead and run these. And then this gives me sort of 3 different models, and this is quite fast. As you can see, it took not more than a few seconds to run it. So now I got my RMSE, and actually I can just quickly look at it. I don't even have to go to UI now, right? This is now somebody who's actually working with the CI/CD tool using the API. So let's simulate that somebody is actually working outside. So I'm going to look at this particular model over here. 210 seems to be the best one. So I'm going to pick that as my version 4. So that's what I actually have. So let's keep this version 4. And I'm going to make the transition of that particular model and then put a description in there for annotation later on down the people who actually load it. And I'm going to test this particular model to see whether we can actually test this in our forecasting application. I'm going to transition that to the staging so the reviewer can actually check out the staging model and then run it into their forecasting. So we're going to stage this particular model. So we made the transition and then see how this looks. Like I said, this is far more better, right? It's actually tracking really well and very close to what the true values are. So I'm confident that this model probably is far more better than the Keras. So we're going to actually use that to deploy that in our production. So you can think of what I've actually done is kind of an A/B testing, but not in the deployment environment, but in my CI/CD tool, where I have a Keras model that I deployed and that I registered with the registry, and I checked out different versions. So I integrated with my forecasting to test to see how good the accuracy were over a period of time. Then I built another experimental model with random forest with 3 different parameters, chose the best particular RMSE that I got, and I used my forecasting application, my testing environment, to see how it actually tracked with the true predictions as opposed to the predicted one. And then this one seemed to be probably the best one. So I'm going to go ahead and choose that. And either Shannon or Leila or Len would say, okay, this seems like a good way to put that in production. And I'm going to transition that particular model into production. And I don't have to go to the UI. The reviewer can actually use the API that we actually saw in our registration, in our presentation. So this is my model that I'm transitioning. And then I'm going to go ahead and now use this model to make sure that it is the actual model that I have. And this is now my production model that actually did the forecasting. So that, in essence, is really the way we actually do the use the model API and the UI to actually use model registry within the notebook, or you can actually do that from your IDE or from your local Python file. So that, in essence, was the demo of how you actually would use model registry in a notebook. And this one, remember, this was the model managed version of the registry, not the open source. So I'm going to do something very similar now on my local host, but a smaller version of this. Okay, so let's go to my host now over here. And I'm going to use, now those of you who were brave enough yesterday or today probably did the install your MLflow, MLflow, and all the other packages that I made that's part of the README. Hopefully you actually went through this to install MLflow on your local machine. How many of you actually were successful in installing this part 1 through 6 on your local machine? Anyone?
You guys can
silent
chat too to answer the questions.
Huh?
I just a reminder you can respond in the chat.
Oh, okay. Okay.
Questions.
All right.
Everybody's so quiet today.
All right, fine. Then silence is a form of complicity. I like that. All right, brilliant. So then we'll just carry on. So what I'm going to do now is run the same thing, but not exactly identical, but something very similar. I'm not going to train the Keras model, but I'm going to use use my IDE where I actually loaded in my Python PyCharm. I'm going to go ahead and run this. Now, notice one thing I've done is I've set my tracking URI to be SQLite to run on my local machine. By default, it creates this particular DB file, which is Alchemy compatible. So I'm saying, from now on my local machine, my tracking server is running locally, and I'm going to use the SQLite to store all my entity data on the local host. This is my WinPath for my data. Same utilities I'm using for classes, same pandas, and pretty much the same code, right? I have pretty much taken this code and put it in a notebook. Because these are sort of very modularized in classes, I can repurpose this particular one. I'm just going to go ahead and iterate over 3 different parameters, 3 different tuning parameters, and run it. I'm going to call this forecasting model. And then I'm just going to go ahead and create load my test data, and then deploy this model from the registry into my local server and then do the scoring, right? One of the things you can actually do is that you can check out a particular model from a registry and then run it locally, or you can actually deploy it remotely as well. We won't get into deploying remotely because it's a bit involved in terms of setting up the configuration for say, if you want to deploy it on the SageMaker or Databricks, but there is a command line utility for you to actually provide the configuration to create a cluster, and it will deploy in that particular cluster. But for simplicity and because of the time's sake, we're going to do it on local host. Okay, so let's go ahead and run this. So this is going to run is going to give me three different metrics, and I'm going to pick up 2 and then use the UI to go ahead and do the MLflow registry UI. So the second thing I'm going to run, I already done this. So this is what I did, but I did it from my PyCharm. I'm going to go ahead and launch my backend UI. I'm going to use my MLflow UI, and giving the argument saying I'm using my backend URI where all the model registries and all the tracking data is available. And by default, the artifact store is going to be a directory called MLrun. So if I go over here, you will see that I have a directory called MLruns, and I have a directory called, and I have a file called MLrun. So let's go ahead and load this. And that's going to launch a local UI for me. And let's go ahead over here and launch this particular server, right? So this is the open source version of the UI. It looks very similar, except that this is not within the notebook. You're actually running that as a Flask Unicorn server. And I can actually go ahead and look at my RMSE. I'll pick up the best one. So let's go ahead and put this. Let's look at this one. click on this one, and this is my model, and I'll go ahead and register the model here, which I did very similar to what I did. Power forecasting model. Register this model. That creates a version 1. And I can actually go to version 1 and then make the transition. Now you notice that it's a bit slightly different over here. You actually don't have different approval process because we don't have permissions available or an RBAC involved in the open source. It's pretty open. Anybody can do that. So I'll just go ahead and put that into production. I'll go back and take the second model that I have. And let's put this one into staging. Now we already created a particular model with the first versions. I'm just going to use the same thing. And when I select the same thing and I register it, this is now going to create a version 2 of the model. So I can go ahead and make the transition into staging if I want. And if I go to my power forecasting model, I actually have 2 models. One is in production and one is staging, right? So let's go back now to our exercise over here and see what would we do now. So the second assignment is to go ahead and deploy this particular server from the registry, right? We're going to take the production version of it and we're going to go ahead and deploy it, right? So let's go ahead and do that. So I don't need the UI. I'm going to kill it. And I'm going to go ahead and deploy this. And if you look at this deploy shell script, all it's actually doing is actually taking the production name of that particular model, is setting the tracking UI to say, go ahead and this is where my registry is, and then go ahead and serve the models. And here's my URI, here's my model name, here's my registered model, here's a production, and then don't use my Conda environment. I don't need that because I'm already running within a Conda environment. So this is now is going to particularly serve the model on my local host with this particular Unicorn host. And I can go ahead and now do prediction on this particular model by doing, so if you look at make prediction, this now, if you look at this particular file, make prediction, all it's doing is actually calling it's invoking, sending a post request, a REST API with this particular format for my records. So these are all my data that actually I'm sending, and then I'm getting a prediction back. You can actually do that using also the Python. I can actually go over here and use pretty much the same thing by sending a post request to this particular server where I'm sending this particular JSON oriented record as my data to give me the power prediction that I have. So that in essence is model registry. You can actually use the managed version of Databricks to get all the enterprise features where you actually can provide rollback access control and so forth. One thing I actually didn't show you was the ability for you to actually go to and set permissions so that people can actually either can manage a particular model whereby they can create a model, they can register a model, they can delete a model and so on and so forth. Or you can actually provide a rollback access control to a group of users who can check out, check in and use the APIs. So these are the enterprise features which are sort of available on the managed version of it, but they're not currently available in the open source. So that in an essence covered our, I know we had a lot of material to do. You have exercises and homework to do at home. So at this point, I think I should end and stop here to ask any questions or answer any questions people might have. Let's see.
Yeah, I think there's maybe 1 or 2 questions in the Q&A, Jules. Are you able to see that, or I'm happy to?
Okay, I'm looking at, are there any pros and cons between the 2 flavors of the registered model? No, there aren't. I mean, obviously there's always there's always the native flavor that people somehow prefer because then you actually can use it natively. Let's say you created a Keras model in a Python flavor and you want to use the Keras one, you really don't care about Python function because you don't want to load the Python function and have the ability to interpret that and then hand it over to the underlying Keras to do the prediction. So I think that's the only difference. But the multiple flavors allow you to create, say, a Keras flavor, a PyFunk flavor that you can actually deploy it on a Spark to do batch processing, or you can actually deploy it on a streaming server to do modal referencing, or you can actually create another flavor, say XGBoost that has an MLib flavor, no, Spark, that you can actually create 3 flavor, a Python function flavor, a Spark flavor, and an MLib flavor that you can deploy it in different versions. So it's not so much that one is better than the other. It depends on how you actually want to use it. But the whole idea behind flavor is that it gives you the flexibility to do that. I missed the stage production just as tags that one can create. No, these are currently the predefined tags, none, staging, production, and archived, that when you actually get by default. There have been suggestions, and there have been a couple of PR requests where they want to have multiple stages, so people can actually configure those stages, and we are kind of making that as part of our roadmap to say, hey, if you give a particular file, you can actually create those stages. So this has come up, right? People do want to be able to not be compliant to using only the default stages, but they want to use the stages in their own environment. Okay, do you recommend use dbConnect in combination with MLflow code tool in local and deployed? Yeah, I mean, you can use dbConnect. Yeah, dbConnect is actually a great way for you to use things locally. I mean, you know, I enjoy working on PyCharm, as you can actually see. I do all my development in PyCharm, and then dbConnect is actually a good way to connect your local machine to a remote server. So I can essentially develop everything locally. I can track and deploy everything on the Databricks. So you can dbConnect is actually a great way to do that. Talking about dbConnect, I think that gives me the inspiration to write a blog to show how you can actually do that. So thanks a lot for the question.
I think that's it. That was easy. Easiest Q&A ever, right, Jules?
Oh, lovely, lovely. Either that or I just totally bored them out of their minds. But well, I want to thank my panelists for helping me out today. Karen, thanks a lot for hosting it. All my participants and attendees who attended. I'm going to put my, where's my PowerPoint presentation here, my creds here. Where did it go? The slides are available. You can just send me an email at jules@databricks.com. If you have any questions, connect me on LinkedIn, DM me on Twitter as well. I'm more than happy to answer any questions that you actually have on YouTube. And we have a Slack channel for Databricks. All the way how to get started with MLflow are on the slide. So feel free to participate, and feel free to send me any questions you have. And thanks a lot for attending.
Thanks everyone for joining us, and thanks Shannon, Layla, and Land for TAing. I know there wasn't too many questions, but it's always great to have you there in the Q&A just in case for the attendees. So with that, I hope everybody has a great rest of your day, and thanks for joining. Take care.
Be healthy and be safe. Thank you.